Hello everybody. In today's lesson we're going to talk about graphing cube roots. So let's get started. Alright, remember that a parent function is the basic function graph. Today we will talk about cube root functions. Let's write that down. Cube root functions look a little bit different than the square root functions that we talked about earlier. A cube root function has a cube root right there. So that's one major difference rather than a square root, which is that number without it. And what we're going to do is we're going to just graph some of the basic tables. So I actually graphed this on my graphing calculator already, so you can kind of see this is what a cube root function looks like. It's almost like a square root. This part is the square root part, but then it has a tail. And so if you look at, if I do second table, you can see some of the nice values, right? You see -1, -1, 0, 0, 1, 1. And then I want some more. I want one more, 8, 2. And I'm going to assume that there's another one on the negative section since it's symmetrical, -8, -2. So those are the values we're going to use to create our original table. The decimals are nice, but I want the whole numbers if I can. All right, so let's go ahead and write them. We have -8, -2. We have -1, -1. Yep, -1, -1, 0, 0. We have 1, 1, and we have 8, 2. So those are our values. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So here's what our shape looks like. It's just, that part is just like the square root. It's a little bit, compressed, but, and then it has a tail. So that's what a cube root looks like. Now, when we talk about the domain, and if I were to ask you, how far right and left does this graph go? Hopefully you say, well, it goes right forever and left forever because of the arrows. So the domain is -infinity to infinity. And then the question changes, well, how about the range? Meaning how far up and down does this go? And this graph keeps going up very steadily and slowly, but it does. And it keeps going down very steadily and slowly. So it goes to -infinity to infinity as well. As a matter of fact, with odd roots, the domain and the range will always be -infinity to infinity. So something to keep in mind. All right. Let's talk about, so we're going to be graphing these but with some transformations, but let's review transformations one more time. So a cube root function with all of its transformations will look like this. Okay, so the function bends at h comma k, so it's not a starting point but more of a bend, kind of as you saw like that. So that's the bend part that we're talking about. Inside underneath the radical, so the x minus h part controls the left and right. And remember that it is always the opposite of what you think. Outside, not underneath, the plus k part controls the up and down, and it is what you think. Okay, so if you think it's up, it's up. If you think it's down, it's down. That one is not opposite. And then at the end, so we'll move the graph up and down. So that's the end part. In front of the radical, the A part that we're talking about is going to help us with the stretch or the compress. Sometimes we call it expand. So the expand means the same thing, just so you know. And then negative next to radical, that's going to be a reflection with respect to the x-axis. All right. And then the order in which we graph these is we list the inside first. Anything on the inside of the radical. So you look inside the cube root, talk about that first, and then you talk about everything on the outside from left to right, which is fine because that's the way we read things anyways. All right, let's get started. Let's talk about transformations first. So starting point or the bend, it's what we see inside, which there's nothing there, so nothing is 0. And what we see on the outside is -5. Remember that the inside switches, but the outside stays the same. For this one, the inside is -4, so it's going to switch. So it's +4, and there's nothing on the outside, so that's going to be a 0. So those are the starting points or the bends for this. And then we have the transformation. On the inside, we have nothing, so we're not going to talk about anything. Now we're going to go left to right on the outside. So we're first going to talk about the 4, and that is going to be a vertical expansion of 4. And then we're going to talk about the minus 5 that's on the outside as well. And what that means is move down 5 units. Okay. Now, we're going to start with the inside on this one because there is something on the inside. We have the x minus 4. And we always take the opposite, so it's actually positive 4, which means move right 4 units. And then we're going to look on the outside. There's nothing on the outside here, nothing behind the radical. So we are done with all of our transformation discussions. That's all we have for that particular equation. All right, let's keep going. This is just a list of transformations again that we talked about, just showing up again. So let's do a couple more examples of this. Once again, we're going to do the starting points or the bends. Here for the inside, we have nothing. Nothing is 0. Here for the outside, we have nothing. Nothing is 0. And then for this one, in number 5, here we have x plus 2. So we're going to switch that around to negative 2. And then we have a negative 5 on the outside. We'll keep that the same because x is the only one that's opposite. All right, let's talk about the transformations. The only transformation I see, there's nothing on the inside. Now, the only one I see is a negative, and the negative will, do you remember? Will be a reflection with respect to x-axis. Okay, so it doesn't mean necessarily over the x-axis, but kind of like if there was a pretend x-axis there, it would just be reflected over it from wherever it's at. And then we're going to talk about the inside here, the x plus 2 first, which means move left, because it's always the opposite of what you think. Left 2 units. And then the next thing we'll talk about is the front. There's nothing there, so we're going to talk about the negative 5 behind it. The negative 5 will tell us to move down 5. That one we believe. All right, we got 2 more graphing examples, and then we're good to go. So let's graph some of these. Okay, now you can use your graphing calculator on all of them, but I think it's kind of fun to do it without it. It's more of a challenge. All right, so let's try to do it without it, and we're together anyways. We'll figure it out together. All right, let's look at example 6. First is the starting point, so it's opposite of what I see there, so positive 2, and same as what I see there. So 2, 5 is our bending. I'm going to put that right in the middle. Okay. Oh, I think I have an extra one. I'll just get rid of one of them. So I'll put 2, 5 right in the middle. This is my starting point. Now, with cube roots, there's no undefined section. There's all the points will apply. So we just got to pick the right and easy numbers. Okay. I'm going to go ahead and start with, I'll do 3. And let's see what happens when I put in the cube root of 3 minus 2 plus 5. Well, the cube root of 3 minus 2 is 1. And the cube root of 1 is 1. 1 plus 5 is 6. So that's going to give me a value of 6. Okay. Now, I want to pick something that's going to make that equal an 8. Because I know that the cube root of 8 is 2. We learned that in the first page. Okay. What would make this 8? Well, 10 minus 2 would give me an 8. So I'm going to make x 10. So cube root of 10 minus 2 plus 5. I'm just trying to get a perfect cube. Okay. So the cube root of 8 plus 5. And the cube root of 8 is 2 plus 5. You're going to see that so much this lesson that you're going to memorize that by the end. So that's 10, 7. And then we're going to go ahead and go the other way. I'm going to do the same thing with 1 and input that. Cube root of 1 minus 2 plus 5. That's cube root of negative 1 plus 5. Now, you might be going, is that imaginary? And the answer to that is no, because it's a cube root. So cube root of negative 1 is actually negative 1 plus 5, which then gives us a 4. So that's going to be a 4. And now we need to find a number for x that's going to give us a negative 8 inside. Because I know that the cube root of negative 8 is negative 2. Once again, from the first page. So what can I add to negative 2 to get negative 8? Well, negative 6 will do it. So when I do cube root of negative 6 minus 2 plus 5, that's cube root of 8. Oh, negative 8. And cube root of negative 8 is negative 2. Add that to 5, you're going to get 3. So those are our points. 5 points that it's going to give us our shape. So let's plot them. -6, 1, 2, 3. 1, 4. 2, 5. 3, 6, and 10, 7. You can kind of see this is our starting point. So here's one half of it, and here's the tail end of it. All right. Now, what's nice about the domain and range is when they ask, hey, which ones are included, you are just going to circle all of them because domain and range on cube roots are all reals. Everything, every single number works. All right. Let's do this one more time. See how it goes. All right, we have -3 cube root of 8. So starting point inside is nothing, so nothing is 0. Outside is nothing, so nothing is 0. So our starting point is 0, 0. I have an extra point again. I'm going to put that in the middle, 0, 0, and I'm going to put SP for starting point. And then I'm going to pick some perfect cube roots. Now, it's so nice because I know that 1 is a perfect cube root, and I know 8 is a perfect cube root, and -1 and -8 as well will work. And then we'll just have to do some math. All right. So when I put in -8 in here, we get -3 cube root of -8. Cube root of -8 is -2. So -3 times -2 is 6. So that's our first point. We're going to do the same thing with the other ones. Let me just kind of cut that off. -3 cube root of -1. Well, that's -3 times -1, which is 3. So we have our cube root answer for -1 as well. All right, we're going to do the same thing with 1. Let me just kind of do this. All right, so when I put -3 cube root of 1, cube root of 1 is 1 times -3 is -3. So that's going to be our answer for that. And then let's do 1 for 8. What if I did -3 cube root of 8 for the x? Cube root of 8 is 2. And multiply that by -3, we get -6. So we have all of our values. So we're just going to plot them. -8, 6. Here's one of them. We have -1, 3. We have 0, 0, 1, -3, and 8, -6. So now we have our cube root. Ooh, looks good. And for the domain and range, we know that it's all real, so we're going to circle all of those. All right. Well done today. Hopefully you are more confident with graphing cube roots. If you need more help, please don't forget we're always available. See you soon. Bye-bye.